Welcome back to another session. We have been solving some problems from the lesson 2 polynomial. This is the final topic from lesson 2, division algorithm for polynomial. So far we found out the zeros of the quadratic polynomial only. So what if it is given the bigger polynomial like cubic or more than 4 degrees polynomial? It is bit hard until it is given one or two zeros, we are able to find the rest of the zeros. Let me explain. Look at here, I written the quadratic polynomial which is 2x square plus 3x plus 1, where in which we able to find the zeros of the polynomial by splitting the middle term, which gives me x plus 1 and 2x plus 1. Here we found out the zeros of this polynomial easily. So look at here the cubic polynomial 3x cube. Okay, p of x equals x cube minus 3x square minus x plus 3. This is cubic polynomial. So how to find the zeros of this polynomial? It will be hard until they given one of the zeros. If one of the zeros is 1, if it is given, we able to do the division rule, divide these polynomial by one of its zeros, which is the factor of this polynomial. That means x minus 1. Since it is given the one of its zero x equals to 1, I am able to write x minus 1 as the factor of this polynomial, right? Once we divide these two, we get the quotient and continue the process till we get all the zeros of polynomial. Let me do this. I put the bigger number. Usually the bigger number is the dividend, right? So I put the bigger number x cube minus 3x square minus x plus 3 inside. I'm going to divide this polynomial by one of its factor, x minus 1 polynomial. To perform this, take the first term from each dividend and divisor. So which is the first term is x cube. I divide them x cube by x, and I get x square. This is what the first term of the quotient. So I'm going to multiply these two, x square into x. First I take multiply these two, x square into x cube. Next, the next term, x square into minus 1 minus x square, right? Then I change the sign, so minus plus. Then I cut this. Then remainder is minus 2x square. And the next time I bring this down, minus x. So again, take the first term, which is minus 2x square, divide by the first term, which is x of the divisor. So I get minus 2x. This is what the second term of the quotient. So now I multiply again, minus 2x into x. I will get minus 2x square. Then minus 2x into minus 1, which gives me plus 2x. I change the sign and subtract them. I cut this one. The remaining is minus 3x. So the last term I bring this down, which is plus 3, and I continue the same procedure, which is minus 3x by x. I get minus 3. So this is the last quotient. So minus 3. Again I continuing the multiplying with divisor, which gives me minus 3 into x, which gives me minus 3x, and minus 3 into minus 1 plus 3. Again I change the sign, minus, So plus here minus. So I get 0. Okay, we found out the quotient and remainder, which is the quotient is now it's in the form of quadratic polynomial. Now it is easy to find the other zeros of this polynomial by splitting the middle term. Now the zeros of this quadratic polynomial is x plus 1. So I am splitting the polynomial x minus 3. And already we know that the x minus 1 is also one of the zeros of the polynomial, and we derive the x value from all these, which gives me x equals minus 1 and plus 3 and 1. This was all the zeros of this cubic polynomial. Okay, let's see our division algorithm for polynomial. It satisfies our division lemma, which we have learned in the previous lesson. Dividend equals divisor into quotient plus remainder. There the OR limit must be less than b and is greater than or equals 0. This is what division lemma, right? Sorry, Euclid's division lemma. Is it? So from these calculations, our dividend is this one and our divisor is this one, x minus 1, and the quotient is this and our remainder is 0. I substitute all those values in division lemma. I substituted all the values in the division lemma. Once I solved this RHS side, I got the answer exactly like LHS side, so which is dividend. Now our division rule is verified for our polynomial. From this, we able to conclude that the division lemma rule is not only for the integer, it is applicable for the polynomial also. So by this way, we can check our division, our calculation is correct or not. Hope you understand. Thank you.